Good afternoon, class. We are looking at the final exam review that covers from section 1.6 to 5.4. We have differentiation formulas as you have seen them before. We have delta y, which is f of x plus delta x minus f of x, versus dy, which is f prime of x times dx. Delta y, change in y along the curve, dy, change in y along the tangent. So if we call this pair a comma f of a, linearization simply means find the tangent line y minus y1 equals m times x minus x up. To be comfortable with logs, if we can go from logarithmic format to exponential format, using this arrow, b to the power of y is x, all the properties of logs for a general case where b must be positive and it can't be 1 is understood. And then translation into common log when the base is 10, fairly easy. And into natural log when base is e, the same thing. So from here to here to here. And of course, the graph of exponential functions and logarithmic functions are symmetric with respect to the line y equals x because they are inverse functions. Here's the change of base formula. The general format when we want to take a derivative of log, if the base is e, just flip it over, and if need be, by the chain rule multiplied by g prime of x. However, if the base is not e, using the change of base formula, we also need 1 over lnp. Integration or anti-differentiation, the reverse process of differentiation. So as long as we're comfortable with derivatives, we have no problem with integrals either. This is FTC, fundamental theorem of calculus. The derivative of the integration results in the function. They undo each other. And the integral of f of x dx, as we evaluated from a to b, this is a definite integral. The result is a number, capital F of b minus f of a, where capital F prime of x equals lowercase f of x, and the substitution method, which is the reverse process. Now, let's start with a very simple example here. We want to differentiate y equals 4 over square root of x squared plus 3. So we're going to take this to the power of 1/2 and bring it up. Now, 4 times negative 1/2 times the same thing to the power of 1 less, right? This is the power rule. So x squared plus 3 to the power of minus 1/2 minus 1 by the extended power rule or the chain rule, the derivative of the inside, which is 2x. This 2, the product is negative 2 with this one is negative 4x. This is negative 3/2, goes down, becomes positive 3/2, or we can write it as the square root. We are going to use the extended power rule. 5 sits in front. The same thing to the power of 4. And I'm going to use the quotient rule. This is f over g. So f prime, which makes it 2 times g, x minus 8, minus g prime, which makes it 1 times f, which is minus 1 times 2x plus 3. And the bottom squared. 2x, going to distribute it, minus 16, minus 2x, minus 3, and these two cancel each other. These two give us negative 19. So negative 19. We're going to rewrite this as 5 times the parentheses. I'm going to write 2x plus 3 to the power of 4, x minus 8 to the power of 4. This is negative 19 in the numerator. So what happens is 5, 2x plus 3 to the power of 4 and minus 19. They go to the top. The product of these two is negative 95. And the product of these two, we add up 4 and 2 by the exponential rule. Again, we've seen all of these questions. We quickly recap things we have seen before so we can move on. Differentiate implicitly. We put a raised dot here, which means we are looking at f times g, and we're going to use the product rule. 4x squared gives us 8x times y, and y gives us y prime or dy dx times 4x squared. So that's f prime g plus g prime f. This is the one. 2y squared gives us 4y y prime, any number, e, 5, 10, pi, any number gives you 0. We combine these two and we move the 8x y. And to combine them, we factor out the 4y prime. We divide by 4 times x squared plus y squared, and becomes negative 2xy over x squared plus y. Whenever we deal with trigonometric functions, I like to differentiate it in the following manner. I'm going to read y equals cosine, and I'm going to pause. And we know the derivative of cosine is negative sine. So you need the argument. It's the same argument. And then by the chain rule, you need its derivative, which is 12t cubed. Or if you look at this one, the derivative of cosine of gx is minus sine of gx times g prime of x. This is what it is, and we're going to put that in front. The final answer is negative 12t cubed sine of 3t to the power of 4. A small rock is dropped into a lake. Circular ripples spread over the surface with the radius of each circle increasing at a rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. First, I want to make sure that everybody knows all the basic geometry. So various shapes such as circle, rectangle, square, sphere, things like that. You should know the volume, you should know the area, you should know the basic information about the rectangular solids, you name it. For example, when we deal with a circle, this is the radius, diameter is 2 times that. When we go around it, we cover the circumference, c equals 2 pi r. We are interested in the area with the formula pi r squared. So this is the one we need. Now, let's write what's given symbolically. Of course, a equals pi r squared. The radius is increasing, so the r dt at this rate, 3/2 feet per second. We want the rate at which the area is changing. We want the ADT at a precise moment when r is 4 feet. So this is the translation of this question. We want to differentiate this with respect to t. T is the independent variable. So the ADT is pi times, now you look at r squared, and you say the derivative with respect to t is 2r dr dt. You rewrite it as 2 pi r dr dt. You replace the r with 4, dr dt with 3/2. And so you get 12 pi units of A over the units of T, 12 pi square feet per second. You should always write the exact answer. If they ask for decimal representation, then you write it accordingly. This is a must, always in your notes. Find dy dt, which means t is the independent variable, which means the derivative of x is no longer 1, rather dx dt. So 4 sits in front, 5x plus y to the power of 3. By the chain rule, the derivative of the inside, 5 dx dt plus dy dt minus x minus dx dt, and any number results in 0 when you differentiate. We could solve for dy dt, but there is no need, just plug in dx dt, x, y, just plug them in. Everything is given, we find dy dt. So to do so, 10 minus 9 is 1, and when you cube it is 1. So you distribute and you get 60 plus 4 dy dt. -60 and -3 is 57. You move it to the right, becomes negative. You divide by 4, and that's dy dt. The value of dy dt is -57 over 4. A 20-foot ladder leans against the building. The base of the ladder slips away at the rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. So here's the building, here's the ladder. It's moving this way, creating this shape. So it's moving this way, and the y comes down. So we have this fixed side. The ladder has a fixed side, which happened to be the hypotenuse in this case, and it's 20 feet. This moves this way at a speed of 2 feet per minute. This comes down at a speed we need to find, or at a rate that we need to find. And because this is a 90-degree angle, we follow Pythagorean theorem, which indicates a squared plus b squared equals c squared. So x squared plus y squared is equal to c squared, which happened to be 20 squared. So that's the formula we need. We also know dx dt. We want to find dy dt at the moment that the base is 12 feet from the building. So that is the translation of the question in essence. We are going to differentiate this with respect to t. So this becomes 2x dx dt. This one, 2y dy dt, any number. This is 400, everybody. But it makes no difference. Any number results in 0. As you notice, we have all the values except y. So into this formula, when x is 12, if I plug in x equals 12, I can find the y value. So x squared, 12 squared plus y squared equals 20 squared will result in y being 16 feet. Now we have everything we are going to plug in. 48 plus 32 dy dt move the 48 divide by 32, so minus 48 divide by 32, both of them are divisible by 16, negative 3/2 feet per minute. But I want you to notice x is increasing, dx dt is positive, y is decreasing, dy dt must be negative, and that is the case. To find the limit, just plug in. I remind you of what we did when we did the limits. It gives you a number, you're done. It gives you a number over, it gives you 0 over a number, any number other than 0. The answer is 0 and you're done. It gives you a number over 0, you have to figure out positive or negative infinity, because when you divide a number by 0, it blows up to either infinity or negative infinity. And 0 is the only number that to the left of it is negative, to the right of it is positive. However, in calculus, most of the time we end up with indeterminate forms of 0 over 0, infinity over infinity, infinity minus infinity, and so on. So over here, when you take a limit as x approaches infinity, you're dealing with a fractional format or a rational function. You divide by highest degree term by, which is x. If you plug in, you get a infinity over infinity. So you divide by x squared, everybody. As you know, this goes to 0 because x goes to infinity. This goes to 0, so the answer is 2. Now, in this case, whether you factor or not, it makes no difference. However, if you factor, it makes life easy. In general, you want to put any fraction in its lowest term. So there is a common factor of x plus 4. And so we deal with this. In this case, now we are going to divide by x. The highest degree, the highest value in the denominator. And that results in the same answer. What matters is that for a question such as this one, if you don't factor, you end up with 0 over 0. So this, if you plug in, it's 0 over 0. So you must factor. We already have the factored form. If we plug in minus 4, the numerator and the denominator both become negative 8. The answer is positive 1. When you look at this case, if you just plug in class, you get 0 over minus 16, which is 0, okay? However, if you deal with the factored format, because that's normally more proper, that will also give you 0 over negative 4, which is 0. So in both cases, you end up with 0. It's not that big of a deal. I like you to see these questions side by side because x is approaching 4. It doesn't matter from the left or right. The bottom is 0, but we want to figure out with more details what happens. So when I say the bottom is 0, you have to figure out the left or right for the sake of infinity becoming negative or positive. So first and foremost, we use the factored form for both of them. Secondly, it's important to know 4 from the left or right, the numerator is very close to 8. In both cases, the numerator is 8. Whether it's 7.999 or 8.001 makes no difference. But the denominator, which is 0, makes a difference. So let's plug in and see what happens. So when you plug in, you get 8 over 0. But is it 0 from the right or left? So you pick 4 from the left, which means like 3.9 minus 4, and that makes it minus 0.1. So it's 0 from the left, and now you know the answer is negative infinity. Whereas here, you get 8 over 0 again, but this time 4 point, let's say 1 minus 4 is positive 0.1. So 0 from the right, and therefore it's positive infinity. That's how I figure out when I get to the denominator of 0, okay? Just plug in, and e to the power of minus infinity becomes 0, and the answer is 3. And here's the reason. A to the power of minus m is 1 over a to the power of n. Therefore, e to the power of minus t is 1 over e to the power of t. For that, e to the power minus t, that means e to the power minus infinity, which means 1 over e to the power of infinity makes it 0. In this case, e to the power of infinity gives you infinity, and any number over infinity is 0. And by the way, the bottom, 3 times infinity is infinity, 3 times infinity plus 4 or 4,000 or minus 10,000 makes no difference. The denominator is infinity. In a case like this, I hope you realize part C becomes identical to part A, because t is approaching negative infinity, unlike that is infinity, but it's e to the power of t. What about this one? Replace the t with 0. As you know, e to the power of 0 is 1. So 12 divided by 4 plus 3 or 7. Again, class, these are questions we've seen quite a few times already. So I hope it's coming back to us, okay, in case. Let's switch gears and do the differentiation. Anytime the numerator is a number, you don't have to use the quotient rule. Just bring the bottom up with the power of negative. Now we're going to use the extended power rule. So first we need number 12. Then according to this n, so we need number -1. Then according to this, we need the same thing to the power of -2. And finally, we need g prime of x, or in this case, g prime of t. The derivative of the parentheses is 3e to the power of t. 12 times -1 is -12 times 3e to the power of t is -36 e to the power of t. This goes down and has a positive exponent 2 now. Let's factor, and notice all of them end up being 0 over 0. So the first one, the technique is factoring. And you plug in, you get 10 over 5 or 2. The next one is called a complex fraction. Technique is LCD. Multiply the top and the bottom by 4x over 4x. And 4x times 1/4 is 4, times 1 over x is 4. And the denominator, you just write it. These two cancel each other. And if you plug in -4, you get to the answer. Part C, again, you get 0/0. The technique is to use the conjugate A minus B. Its conjugate is A plus B. Resulting is A squared minus B squared. So you're going to multiply and divide by it because this fraction must be 1. So you write the bottom as a product and the top, this comes out minus 1 squared, which is 1. These two cancel each other. These two cancel each other. The numerator is 1. If you plug in 0, the square root of 1, this is 1, this is 1, so the bottom is 2. 1/2 is the final answer. Now, this is similar to what we did in the previous page, dealing with the rational numbers. We divided by highest degree term in the denominator. In this case, the highest value would be e to the power of t, so we would divide everything by e to the power of t. The highest value in the denominator. We simplify. As you can see, this goes to 0, this goes to 0, so positive 1 over -3, or simply -1/3 is the answer. You want to differentiate this, we put a raised dot. So we have FG, the product rule. So the derivative of e to the power of 2x is itself times 2, times ln x. This is f prime g, plus g prime 1 over x times f. And you just factor out e to the power of 2x, you get 2 ln x plus 1 over x. Again, just in case, this is f prime g. G prime. Anytime you're dealing with logs, the first question is, can I decompose it to make it easier? In this case, the answer is no. So first thing first, flip this over. Then by the chain rule times its derivative, which is 2x. Then you look at the base. If the base is e, you're done. If not, 1 divided by ln b, in this case ln 5, and you just rewrite it. This is ln of the top minus ln of the bottom. Ln of the top is ln of 2 plus ln x. This is decomposition of the log completely. This is a number. So that gives you 0. Ln x gives you 1 over x minus 1 over 2x plus 1 times its derivative, which is 2, the derivative of the argument. And again, you're done with calculus. So the common denominator is x times 2x plus 1. 1 times 2x plus 1 minus 2 times x. This is taking a common denominator. So 1 times 2x plus 1 minus 2 times x. These two cancel each other, and we're done. To find the equation of a tangent line, we need to find the slope. So let's find f prime, which is 2x minus 3, This is not the slope. The slope is f prime of 4, which makes it 2 times 5 minus 3. So 2 times 4, 8 minus 3 is 5. The pair 4 comma f of 4, if I plug in 4 here, I get 16 minus 12 minus 1, I get 3. And now I can use the point slope. Y minus y1 equals n times x minus x sub 1. So y minus 3 equals 5x minus 4. So y equals 5x minus 17 is the final answer. By the way, again, this pair belongs to the original function, also to the tangent transfer. It shows this calculation is correct or not. A doctor prescribes a 300 milligram drug to be taken every 12 hours. Just before each tablet is taken, 40% of the previous amount of the drug remains in the body. You want to write the equation for Q sub n plus 1. First and foremost, because it says Q here, the B will change to Q. Secondly, you always write the given, it makes your life easy. So when we are dealing with patients and medications, B sub 0, or in this case, we're going to call it Q sub 0 or A, is 0. So constantly we give 300 milligrams. How often? Every 12 hours. So this is the constant C. And what matters is what remains in the body, 40% or 0.4. Now, 12 hours doesn't, enter the calculation, but this 12 hours is that indicates this 40%, okay? So instead of Bn plus 1, I'm going to write Q sub n plus 1. And all I have to do is just go back to the given, replace the R with 0.4, C with 300. Q sub n, I'm going to go to this formula and replace the B with Q. And again, given this is 0, R is 0.4, and C is 300. The 300 over 0.6, I write that's 3,000 over 6, which is 500. The reason we do that, so for the next two parts, makes it easier for the calculation. For example, here, how much drug is left after the 5th tablet? Replace the n with 5. Use a calculator. And this is how much is left in the body after the 5th tablet. What is the limiting value? What if you continue indefinitely and you never stop? You take a limit of this expression, and as you recall, because n is approaching infinity, 0.4 to the power of infinity goes to 0. So this goes to 0, so the answer is 500, and you use the units, milligrams. What does it mean? If you follow this is the effect of the 12 hour that remains 40% remains. If you keep on doing every 12 hours, it will never, ever go beyond the limit of 500 milligrams, which they have calculated to be safe for the patient. This expression, I want to do two things. I want to differentiate and I want to integrate because I want you to compare and contrast. Remember, with the exponential, when we want to differentiate, we have to multiply by negative 0.2. So 4 times negative 0.2, and we write the e, minus the derivative of sine is cosine, and we just rewrite this as negative 0.8 e to the power minus 0.2x minus cosine. However, if I want to integrate this, I put the integral sign and I need a dx, okay? So what happens now? Well, when we differentiate, we multiply by negative 0.2. When we integrate, we divide by negative 0.2. So 4 divided by negative 0.2. And the same thing, e to the power minus 0.2x. And this is 4d divided by negative 2 or negative 20 minus. What is the derivative of sine x? Cosine x. What is the integral of sine x? Negative cosine x. Negative and negative makes it plus cosine x and a constant. And we write the final answer. Let's look at an initial value problem where f of 0 is 20, meaning it gives us this pair 0 to 20. Let's plug in. So replace the x with 0. As you know, this is 1, this is 1, so we get minus 20 plus 1 plus c equals 20, and I hope you realize c is 39. And we get this answer, which means this is general solution because we have a constant. It's a family of functions. And this is a particular solution. So we have infinitely many solutions here because of the constant over here. With the help of one pair, we got to the answer. To integrate this, we're going to change the square root of x to x to the power of 1/2. And we are going to write two fractions. This has power of 1, so 1 minus 1/2 gives you x to the power of 1/2. This gives you x to the power of negative 1/2. Everything so far has been an algebraic step. 1 over 1/2 plus 1, x to the power of 1/2 plus 1, plus 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1, and a constant. They add up to 3/2. They add up to 1/2. 1 over 3/2 is 2/3. 1 over 1/2 is 2. And we're done. Let's switch gears and look at substitution. Anytime we have polynomials, the more complicated one is a choice of u. So this is the choice of u. As you know, its derivative is 2x. So du is 2x dx. Be very careful. This was a lot of students made a mistake. Don't make a mistake with the final. And so we're going to move the 2x next to that. And so this is u to the power of 30 du. Simple case of a power rule, 1 over 31, u to the power of 31 and a constant, and u is replaced. We are fine. So the tip is, look for a function u equals g of x anywhere in the integrand, and its derivative du or g prime of x multiplied by dx. That's the technique. All right, let's do this. And generally speaking, anytime you have a fractional format, this is a fractional format, transcendental function. This is a rational function. Concept is the same. The first thing is you simplify if you can. When you can, the choice of u is the denominator. If du is e to the power of t, you put the dt next to it. And this, we know it to be a natural log. Replace the u, and you're done. And again, as always, if you are sure this is positive, which is the case here, you can drop the absolute value. In this case, the denominator is a choice of u. If I differentiate that, I get 2x plus 2. So du is 2x plus 2 times dx, or 2 times x plus 1 dx. So I'm going to rewrite this in the following manner, and notice, by the way, dx is always in the numerator, not in the denominator. Number 2, which is a number, is missing. You can solve for dx, but it's faster if you just plug in the 2 and undo it with the 1. By the way, if you put the 1/2 inside, it's the same as outside, makes no difference. If you put the 2 in or out, makes no difference. It's just a number, it's a multiplier, okay? So you can keep even the 1/2 inside, it doesn't matter. And so we are looking at the same thing again, natural log. Of course, the 1/2 in front is not going to go away. You replace it and you're done. What I'd like you to see is, what if I put the reciprocal of this, and all you have to do is just rewrite this as 5e to the power of negative t, and this one as 1, so you don't need a substitution. And that's really the key here, everybody. So this is 5 divided by negative 1, or negative 5e to the power minus t plus t and a constant. Okay, so that's the idea behind this question. Anytime ln x is involved, that is the choice of u. It's at top, it's at the bottom, makes no difference. Du is 1 over x dx, or dx over x. That's the notation. Both of them are the same, everybody. I'm going to rewrite this so it becomes clear what we are dealing with. Ln x to the second power times 1 over x dx. This is u squared. This is du. Now you're dealing with the power rule. 1/3 u cubed and a constant. Replace the u and you're done. Notice the derivative of the bottom is the top. The derivative of e to the power of x itself. This one is e to the power minus x times negative 1. Therefore, if you choose u to be the bottom, the top times dx is du. So put the dx next to the numerator. So that's u, that's du. So you're dealing with du over u, and that gives you a natural log. Replace the u, and this is one of those that you can lose the absolute value and change it to parentheses, because the expression e to the power of x plus e to the power minus x is positive. Very straightforward, everybody. Pay attention to the fact that this is theta, therefore 5 gives you 5 theta. The derivative of cosine is negative sine, but the integral is positive, so positive 2 sine theta and a constant. Anytime you're dealing with e to some power, the exponent is a choice of u. You know its derivative is 5x to the power of 4 dx. We're going to move x to the power of 4 next to dx. And it becomes clear number 5 is missing. Again, class, you can put both of them inside the integral sign. Makes no difference, just a number. Or you can even put the 5 out. The reason I put inside, I want to make sure everybody can see the combination of all of those is du. But if I have the 1/5 inside, let me just write that. It makes no difference. If you wrote it as the integral of 1/5 e to the power of u du is the same thing. Okay? So let me actually write it here. 1/5 is the power of u du inside, and then delete this. And you replace it, and you're done. You're dealing with a natural log. That is the choice of u. What is the derivative of that? 1/x plus 1 times 1. What is du? 1/x plus 1 times dx. So we are going to put the dx to the numerator, next to the numerator, in this fashion, dx/x plus 1. So it becomes clear, this is u, this is du. Now, what are the new limits? If I plug in 0, I get ln 1, which is 0. If I plug in 1, I get ln 2. So those are the new limits. It's important to have the new limit. So you plug in ln 2. When you plug in 0, it doesn't change anything, minus that. So you plug in ln 2, and you keep it at half of ln 2 to the second power, which is an exact answer, everybody. Sinusoidal functions. Well, when the argument has an exponent, that's a choice of u. Its derivative is 2x. Du is 2x dx. So when I rewrite that, I plug in 2 because missing and 1/2. Again, this 1/2 can be inside, makes no difference. You can't lose that. Becomes half of the integral of sine u du. You know the derivative is cosine, but the integral is negative cosine. So replace the u and you're done. Anytime sine or cosine are involved, the one with the exponent is a choice of u. In this case, sine is the choice of u. Its derivative is cosine x. Du dx is cosine x, but du is cosine x dx. Replace it. Use the power rule and replace the u 1/3 sine cubed x plus a constant. Very straightforward. I gave you this to do it at home, and I went over that, so I'm going to remind you. Cosine has the exponent. That's the choice of u. Its derivative is minus sine x dx. So I put a negative in, negative out to undo that. And so what you're looking at here is u to the power of 20 du, and that gives you this negative sign doesn't go away. Minus 1/21 u to the power of 21 and a constant. That's what you get. So negative 1/21 cosine of 21, cosine to the power of 21x, and a constant. We've seen this question again. Many fish grow in a way that is described by one Bertalanffy growth equation for a fish that starts with a length of 1 centimeter and has a maximum length of 30 centimeters. This equation predicts the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will it be in 4 years? And it uses the accumulated change. So if capital L represents the length of the fish at any age x, its derivative L prime of x, or dl dx, is this. So the amount of increase uses this definite integral from 0 to 4. So you divide by -1, you get minus 29 e to the power minus x. From 0 to 4, you plug in 4, you plug in 0, and you have to use a calculator, everybody, because everything here is an approximation, including this one, okay? So this is the answer. L of 0 was 1. We add 1 to it, and then it says 1 decimal. Then I change to 1 decimal. This changes to 5 because it's 6. And if you recall the second method, we said L of x equals 29 e to the power minus x. We did it here. We ended up with this. So let's write this one plus a constant. And of course, L of 0 is 1, and help us find the constant. So L of 0, if I replace this one with 0, I get 1. So this is this is 1, right? Minus 29 plus C is 1. So C becomes 30, right? And now you want L of 4, which gives you the same answer as here. Very straightforward. All right. The distance in meters of an object from a starting point is given as such. S of t is 2t squared minus 5t plus 40, where t is the time in seconds, but is the velocity of the object from 2 to 4 seconds. That's the average velocity, total time, total distance over total time. So it's S of 4 minus S of 2 over 4 minus 2. I'm going to assume everybody knows what's happening. Plug in 4, plug in 2, and that 4 gives you 52, 2 gives you 38, and we get 7 meters per second. This is elementary algebra. Plug in and observe. What is the instantaneous velocity and acceleration of the object? What is the velocity and acceleration of the object after 6 seconds? First, the instantaneous velocity, you take the derivative. So you take the derivative of this function, you get 4t minus 5. And after 6 seconds, you get 4 times 6, 24 minus 5, 19 meters per second. As you recall, acceleration, you take the derivative again, which gives you 4. Okay, acceleration is the second derivative of the position function. So take the derivative again, and 4 is a constant. If it was a function of t, you would have to plug in 6, but it's not. When does the object reach a velocity of 31? Well, this is v, set it equal to 31. And you add up to 36, divide by 4, and the answer is 9 seconds. Use differential to approximate square root of 27. First, we need a function that represents this, and that's the square root of x. Because all you have to just read square root of 27. Then you need to choose a number close to 27, where you can easily find the square root. The closest number is 25 because square root of 25 is 5. Then the change delta x or dx is 27 minus 25 or 2 because we are going to go from 25 up. So it's positive 2. Again, if they are asking for, let's say, a square root of 24, please understand delta x or dx is minus 1, okay? Because from 25, go to 27, positive 2, but go to 24 is negative 1. So what we need to do is f of x plus delta x is f of x plus dy by the approximation, right? So what is f of x? We have it. What is dy? First, let's find f prime of x. This, by now, we've done this many times before. So this class is x to the power of 1/2. So f prime is 1/2 x to the power of 1/2 minus 1. So 1/2 squared of x. What is dy? The same thing times dx. Let's plug in. So if we want square root of 27, we plug in x is 25, delta x or dx is 2. And we know square root of 25 is 5. And these two cancel each other. So we have 5 plus 1/5. 5 and 1/5 or 5.2. Now, if you look at the calculated result, I hope you see that it's very close. In fact, if you go with 1 decimal, because next to it is 9, you have to change it to 2, becomes identical. However, there are two ways to do that. You can do it by linearization or tangent line. That must give you exactly the same answer. So if you want to do that, what do you need? You need two things. You need a pair. 25 goes into that. You get 25 and comma 5. You need the slope. 25 goes into this. Gives you 1/10. This is how you do the calculation. So y minus y1, y minus 5 equals m 1/10 x minus x sub 1 or x minus 25. You go through the process, you get this linearization. Now you are going to evaluate it when x is 27 and you get to the same answer. Find the absolute max and mean for the given function. We are going to use the closed interval theorem. This is a polynomial function of degree 4, so the domain is all real numbers. Therefore, it is continuous in the given interval of -4 to 1. Now we find f prime of x because we want to find all the critical points. 4x cubed minus 36x. Because we want to set this equal to 0, we are going to factor the 4x out. This is x plus 3x minus 3. So there are three answers. X is 0, x is -3, x is +3. So when f prime is 0, it produces three answers. F prime does not exist, doesn't produce any answer because f prime is a polynomial, it exists everywhere. Now we look at this and say, okay, is 0 in between? Yes. -3 in between? Yes. +3? No. It's not in between. So only 0 and -3. This is an element of. So what do? You go back to the original function and you evaluate it at all of those numbers, the endpoints. F of A is -4, F of -4, F of C sub 1, let's say -3, F of C sub 2, 0, F of B 1. Plug them in, evaluate them. We get these values. All of them are negative except 0, so that's the absolute max at this pair. This is the smallest number. This is the absolute mean at this pair. Now, when you answer this question, you want to be careful as to how they ask you. If they ask you for what is the max, this is the answer. What is the pair? This is the answer. What is the x or the mean? So you want to pay attention to the way they want you to answer it. Evaluate this integral. 25 minus x squared is the choice of u. The derivative is minus 2x dx. The derivative is minus 2x, so du is minus 2x dx. We're going to move the x next to the x. -2 is missing. You can throw it in and undo it. And by the way, again, you can put the -1/2 inside, makes no difference. And I'm not going to write the new limits. We've seen this many times before. This is u to the power of 1/2. So -1/2 remains. This one is 1/1/2 plus 1 u to the power of 1/2 plus 1. And so we get 3/2, 2/3. The product of these two is -1/3. And I can go back to the original limits and work with the original variable. But if I put the 3 here, I get 25 minus 9 equals 16, the lower limit. If I put the 4 here, I get 25 minus 16, 9 is the upper limit. And I can work with that. So I plug in. And this is square root of 9 or 3 cubed, which makes it 27. This is square root of 16 or 4 cubed makes it 64. So we have minus 37. We get positive 37/3. The radius of a blood vessel is 1.4 millimeters. A drug causes the radius to change to 1.3 millimeters. Use differentials to find the approximate change in the area of the cross section of the vessel. It's important to understand you're dealing with a circular shape. So this is the original radius. This is the new one because it shrinks, it gets smaller. And this is the change. So R is 1.4. dr or delta R is negative 0.1 because 1.3 minus 1.4. Area is pi r squared. This is the R, and we want the A. So understanding the question is important, everybody. So this is the translation. So recall that f prime of x is dy dx. So a prime of r is dA dr. In this case, dy was the product of these two. In this case, dA is the product of these two. So first, we are going to differentiate a equals pi r squared with respect to r, and it becomes dA dr or 2 pi r. So dA is the product of these two. Replace the R with 1.4, dr with negative 0.1. Will give us negative 0.28 pi millimeters squared, and this is an exact answer. You write with however many decimals they ask you using a calculator. Now, the exact answer class is the shaded region, which means calculate the area of the small one, pi r squared, r is 1.3. Calculate the area of the larger one, pi r squared, the r is 1.4 for the large one. The difference is the answer. So this is the exact answer, delta A, delta A. So pi times 1.3 squared minus 1.4 squared. As you can see, these two are pretty close. So exact versus an approximation. Here's the last question for today. A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek as seen in the diagram. Find the maximum area. Well, let's throw in X and Y. So the objective is to maximize the area X times Y, where we have 240 feet of fencing. That means 1, 2, 3 X's. Normally we have 2 Y. This side doesn't need it. 3X plus Y is 240. That's the constraint. You solve for Y becomes 240 minus 3X. Replace the Y and it becomes a function of X. Now Y is X between 0 and 80. X is a dimension, must be positive. Y is less than 80. If you set this equal to 0, you get 80. If you choose X to be larger than 80, so first, this one, if you set it equal to 0, X is 80. If you choose larger than 80, this becomes negative, so it can't be. The area becomes negative. So distribute for the sake of the next step, which is differentiation, and A prime of X becomes 240 minus 6X. You set it equal to 0 and you get 40. Since we have an open interval of 0 to 80 with one critical point, this is not only local, it's also absolute. Minimum or maximum, we don't know yet. If you take the derivative again, A double prime is negative, means concave down, means maximum. So maximum occurs when X is 40. So if you plug it into this one or to this one, Y becomes 120. And the maximum area is the product of the two. So the dimensions are 40 by 120. The maximum area is 800 square feet.